Hi everyone, happy snow day. As much as I want you guys to just totally enjoy the snow day, I want to just move forward a little bit with some material so that we're not rushing next week to get you ready for your test. So this video, the background of it will be the handouts that I gave you guys in class on Tuesday. Not filled out, it's a blank one, but so you notice where we left off in class on Tuesday was we filled out this page right here for the general rules for transformation. So if you were absent from class, I posted the notes from Tuesday, and so you're going to want to fill out this sheet so that you have it to move on, okay? Because this gave us all the rules that we used in order to graph a quadratic that was in vertex form, okay? So what I'm going to do, I'm going to switch to the next page. So this is the next page in your packet. And we're going to go through two examples of how to do a detailed graph rather than just a sketch. Where we left off last class was sketching. Last class we said in order to get a detailed graph of a quadratic, we just need more points. Okay, and we had said really we need at least 2 more points. And 2 is good as long as we get them in 2 good points that are in kind of on opposite sides of the vertex. 2 will be enough. So I'm going to show you, a couple different ways we can find those 2 more points here. Okay, so let's start with this one that you've got in your packet. So we're graphing g of x equals negative 2x plus 1 quantity squared plus 2. So the first thing that we're going to do is we're going to find the vertex. You'll have to kind of forgive me for my handwriting on this. It's even worse than when I write in class. So we find the vertex. Last time we talked about all the different shifts, okay? So we know that this graph, I'm going to jot a couple things down here. We know that this graph right here, if I have an x plus 1 there, okay, we know that this is going to make the whole graph, remember this is kind of opposite of what we would think. It's going to go left 1 unit. And then we know that this plus 2 here is going to make my whole graph go up 2 units. So that would make my vertex to be negative 1, 2. So I'm going to plot that point, negative 1, 2. Okay, so from here, if I were sketching it, then I would just look at that negative 2 in the front, and I would finish my sketch and say, okay, it opens down, and it's more narrow. Okay, but for a detailed graph, how narrow do I do it? So we need more points to really show how narrow it's going to be. So we're going to find some more points. Okay, so find more points. Okay, so what points do we pick? And that's kind of up to us. We would like some on both sides of the vertex. So one easy point always to pick is to find the y-intercept, okay, which would mean to do g of 0. Okay, if x is 0, we're going to end up finding the y-intercept. So let's see what happens when we do this. So we get negative 2, 0 plus 1 squared plus 2. So what we get out here, so we have 1 squared, so we have negative 2 plus 2, we get out as 0. So we know another point that we can plot is 0, 0. So that happened to be the y-intercept and the x-intercept, just by chance that we found it because it goes through the origin. Okay. We're going to work on finding x-intercepts later on next week. Right now, I'm not ever going to try to find the x-intercepts. I found that one by chance. But to find the x-intercepts, we have to really know more about solving a quadratic versus this one I just plugged in. Okay, so I need one more point. So what I'm going to do is I'm going to draw in my axis of symmetry, okay, like we were doing in class. So my axis of symmetry is right there. Remember, it's the line with the equation x equals negative 1. It's lined up perfectly with the vertex. And kind of look at that and see that that is a line of symmetry. So I'm going to do a mirror image. So I'm going to do a black point right here, and it's going to be a mirror image of that blue point. So if 1 away from my line of symmetry, the y value is 0, 1 away on the other side should also be 0. So those points are mirror images of each other. So what I'm also going to do to kind of prove this to you is I'm going to find algebraically what g of negative 2 would come out to be, just so I can show you how it works out. -1 is smack in the middle of these two values, which makes sense because the vertex is in the center of this graph, x, using the x coordinate. So watch this. So I get -2, -2 plus 1 squared plus 2. So I get -2 times -1 squared plus 2. Okay, so when I end up doing that, I get a 1, -2 plus 2 equals a 0. Okay, so I have another ordered pair there. So I have 0, 0, and my other ordered pair is -2, 0. And you can see that that was the mirror image of that point. So I just wanted to show you both algebraically and on the graph when I did that mirror image, I got both the same points there. Now you could actually have, maybe you wanted to find g of 4 and see what that came out to be, or g of 2. You could find any point on one side and do a mirror image of the other. It's just usually easiest if I use one of those points to be the y-intercept, because plugging in a 0 is usually the easiest. So that is a nice detailed graph. We've got the vertex, we've got our axis of symmetry, and we've got additional points. And you can see, so now when I drew it and I see all my points kind of together, it did open down and it was narrow, just like I thought in the beginning. So that's kind of a confirmation that everything fit together the way it should. So let's try another one. So make sure you're filling this out right along with me. I'm going to check it in class on Tuesday. Okay, so let's go down here. I'm just going to erase this for a second, if I can. Oh, never mind. Let me undo that. Just if I have a little more. Oh, I can't erase that. I was going to try to give a little more space on this one, but that's okay. All right, so now same kind of thing. Now keep in mind, when we look at this one, I did put the 1 in front, but it's still my vertical shift. So if I want to rewrite it like this, we can. Okay, so let's go through again. This right here is going to make my graph. So I have an x minus 2. So this whole parabola is going to be shifted to the right 2 units. And this is going to make it go up 2 units. Oh, sorry, up 1 unit. So that automatically makes my vertex 2, 1. Okay, and it makes my axis of symmetry the line x equals 2. So we can plot that right now, but make sure you label this as your vertex, because you don't want to get the 3 points mixed up and not know which one is the vertex. So there's my vertex, and here's my line of symmetry, right down the middle. So now I'm going to look at a value and say, okay, a is 3. So when I finish this graph, it should be opening up, and it should be pretty narrow. So that's just so I can have something to check everything with to make sure it all works out together. So again, let's find some more points. So let's do the vertical intercept, the y-intercept. So I'm going to find f of 0 and see what happens. If it's not a point that I like, if it's off my graph, I think this one comes out kind of high, but let's just see. When I plug in all that, let's see, this becomes a -2, squared is a 4, times 3 is 12, so I have a 13. So it's up here. Okay, I'll plot it. It's not a great point because it's off my graph. So I'm just going to plot another one. I'm going to see what happens if I did f of 1. And let's just see what happens there. If it's a better point, I can graph more accurately. So I get a 1 minus 2 squared plus 1. Okay, so this is -1. Squared is 1 times 3 is 3 plus 1 is 4. So another point now is 1, 4. 1, 2, 3, 4. It's just a little more accurate because my graph, it's on my graph. So let me do a couple mirror images now. So if you look at the mirror image of the first one I did of 0, 13. So 0 is 2 units away from my line of symmetry. So 2 units the other way would be right up here. Okay, which would get, just so you'd see, that's another point. That would give me the point 4, 13. Okay, and if I look at the mirror image of my other point of the 1, 4, that's 1 unit away from my line of symmetry. So if I do 1 unit and do my mirror image, that would give me another point of 3, and then what is the y? 4. So each of those are 1 away from my vertex. And if I connect it now, I've got my parabola, not the prettiest parabola, but yours will probably look better on your paper. But it does open up just like we thought. And it is pretty narrow because of that 3 as my A value. So my points, my intercept, my y-intercept, my vertex, they all fit together, and my graph looks exactly the way it should. Okay, so there are 2 examples of graphing it in vertex form. Okay, so you're going to see some more of those on your homework. These you should be able to do no calculator. You would only use a calculator on these to check your graph. Okay, the next couple of videos we'll do will be the same kind of thing, but what happens if it's in vertex form, if it's in standard form instead of the vertex form like this one. So all of these videos you're going to be following along with me in your packet, and then you're going to show everything to me on next class on Tuesday for a quiz grade. Okay, so once you're done with this one and you practice a little bit, then you can go on to the next one.